All right, so we are still talking about two-step equations today, and we're going to start by talking about what happens with one-step equations if you have a fraction coefficient. So if the variable is multiplied by a fraction, I will multiply. This is how you undo a fraction by the reciprocal on both sides of the equation. And you may remember this word reciprocal. The reciprocal of A over B is B over A. Denominator goes to numerator, numerator goes to denominator, right? If I multiply them times each other, I will get 1. Then that's my goal, okay? I want the variable to have a coefficient of 1. Then we basically have it by itself, right? Reciprocal of 5 over 3, 3 over 5. Of negative 4 over 7, negative 7 over 4. Of 7, well, that's 7 over 1, so the reciprocal is 1 over 7. And of negative 13, that's negative 13 over 1, so it would be negative 1 over 13. Let's try a couple. I see a fraction coefficient. I'm going to multiply by the reciprocal. What I do on the left, I do on the right. These will make a 1 pair. That was our goal. We're left with x over here. Fractions work by multiplying straight across the top and straight across the bottom. I have negative 24 over 3, which evaluates to negative 8. Don't forget, we can plug that back into, I'll do it in a different color so you guys can see it a little bit better. Plug it back in to the original equation. Everywhere I see x, I'll use negative 8 instead. We have negative 24 over 4, which is equal to negative 6. So this is correct. I see a fraction coefficient. I multiply by the reciprocal. What I do on the left, I do on the right. I'm left with x is equal to negative 10. And so this is the same thing we did yesterday. It's still, even if there's fractions in there or whatever, we are still just like unwrapping a present. First, we undo the subtraction and addition. Then we undo the multiplication and division. Then the exponents. Then the grouping. Grouping can look like this, grouping can look like this, grouping can look like this. It's all grouping. So the acronym we need to remember, womp womp, sad Meg. We don't know why she's sad, but she is. So this is the same thing we just saw. And really today, yesterday we kind of focused here. Today we're more focusing here and here. So if I have this, what should I undo first? Should I undo this addition or should I undo this division? Well, this was kind of a trick question. So here are these words. Fraction bars create groups. Fraction bars create groups. The first thing that you should do when you see a fraction bar and you don't see a group is draw that group back in. Now using SADMEG, what do I undo first? Well, I don't have addition and subtraction first. I don't have it because this addition is inside of a group and that gets evaluated all the way down here. So I want to undo this division first. What I do on the left, I do on the right. These make a 1 pair. I'm left with 2x plus 4 equals 30. And that undid the group. That undid the group of the fraction bar. Now, I'm going to look at the addition and subtraction. because now I'm back up to the beginning. Now I'm reset back up here, and I'm going to undo the addition and subtraction. 2x equals 26, and undo this multiplication and division. X is equal to 13. I see a fraction bar. I'm adding in grouping symbols. I'm going to undo that grouping first. I now see addition. What I do on the, sorry, I see subtraction, so I do addition. This is a 0 pair. X is equal to negative 11. Which is closer to the variable? Which one of these is more like the box? Well, this multiplication is. So let's undo this addition and subtraction first. I see subtraction, I do addition. What I do on the left, I do on the right. Now I have this fraction coefficient, so I'm going to multiply by the reciprocal. What I do on the left, I do on the right. B is equal to negative 40. These are always tricky because they look like one-step equations, but they are not. So I see addition, I will do subtraction. What I do on the left, I do on the right. Is this solved for x? Is the coefficient 1? No, the coefficient is negative 1. So I have to multiply by negative 1 on both sides to get rid of that. I can divide. It's going to get me to the same place. X is equal to negative 1. And we can substitute that back in. Negative 1 plus 7 is equal to 8. 1 plus 7 is equal to 8. 8 is equal to 8. So we did it correctly. This is the same thing as 2 over 5 times x. There are two ways to solve this. So you can either multiply by the reciprocal on both sides, which is, I'll show you that way first. You're left with 10x over 10, which is equal to negative 30 over 2. This is a 1 pair, and x is equal to negative 15. Or you can treat this as a two-step equation. Multiply both sides times 5. This makes a 1 pair, so you have 2x is equal to negative 30. Divide both sides by 2, and you will get the same answer. Sometimes your answer might be a fraction, and that's okay too, right? Fractions are nothing to be afraid of. 5x over 4 is equal to negative 1. I have a fraction coefficient. I multiply by the reciprocal on the left and the right. And x is equal to negative 4 over 5. Now, are we comfortable with fractions? Could I substitute that back in there pretty easily? With this one you may be able to, but let's see how we do it on Desmos just to double check. All right, so everywhere that we see x instead of x, this is our original equation. And I'll just put it down here so you can see. We came up with the answer of negative 4 over 5. Oopsie. And when I substitute that back in, negative 4 divided by 5, it should evaluate, I can't have this equal sign in here, to negative 2, and it does. So we did that one correctly. Yes, the answer can be a fraction. That is okay. And finally, a little bit of everything, right? We always kind of build up to here. I see a fraction bar. I'm going to create a group. I see division. I do multiplication. What I do on the left, I do on the right. Undo the addition and subtraction. 3x is equal to negative 13. I see multiplication, I do division. X is equal to negative 13 over 3. Well, that can't be right. It's a fraction. Well, let's put it into the original equation and see if it evaluates to negative 3. So we only need the left-hand side here, and it should evaluate to negative 3. The answer that we got was negative 13 divided by 3, and it evaluates to negative 3. So we solved correctly. See, it's fine. It can be a fraction. That's okay. Thanks for watching, and I hope this was helpful.